In image analysis, we don't measure actual gray or color pixels. Instead, we select a range of pixels and assign a color bitplane to them. This process of creating a bitplane or binary plane for a selection of pixels is called binarization. Measurements are carried out on these binary planes. To binarize an image based on its gray levels or intensity, we use gray thresholding. The intensity of pixels ranges from 0, black, to 255, white. For example, we can use the blue bitplane to depict dark features and the red bitplane for the light background. In some cases, the intensity of the features you're trying to binarize is so close to the background's intensity that it's impossible to distinguish them using gray thresholding. On the left is a zoomed-in color image, and on the right is its grayscale equivalent. The blue features seem to blend in with the background when the color information is discarded. In this case, features would be poorly detected using gray thresholding. Once the features in your image have been binarized using one or more colored bitplanes, you'll be working on these bitplanes, fine-tuning them to look more like the features you wish to analyze, then measuring them using various measurement tools. To ensure best results, samples are well prepared, shading is even, lighting is adequate, and microscope parts are free of dust. Color bitplanes are created using gray levels or color information in an image, represent features or phases, are stored as a separate layer, and are a necessary step before carrying out measurements. So what happens after binarization? Bitplanes can be edited manually or automatically, and features can be separated, grown, shrunk, transferred to a different color, removed, and so on. Binarized features can be measured as objects, can be measured as phases, can be sorted by size, can be compared by field, and can be shown as a distribution curve.
Now that you know a bit about gray levels of pixels, let's have a look at the gray level histogram for this image. In the Gray Binary Transformations category, select Gray Threshold and click on Insert. The histogram shows the distribution of pixels in this image by gray level. The small peak on the left represents dark gray pixels, or nodules, and the higher one on the right represents the light background pixels. Okay, next we can choose a bitplane color to represent a range of pixels. In this case we'll go for red and select all the gray levels found in the nodules. So now we have a red binary plane representing nodules on top of our image. Sometimes binarization based on gray levels is too difficult or simply not possible. In this image, for example, the features we want to detect happen to have the same intensity as some of the background pixels. Now let's try color thresholding. Because of the reddish color of the copper, it's very easy to distinguish those pixels from the ones in the background.
By the way, you can use any bitplane for thresholding.
Binarizing an image, or in other words creating a binary plane to represent those features you want to measure, is only the first step in image analysis. A typical routine will have steps to fine-tune this binary layer and then to measure it. All you have to know at this stage is that this binary plane exists. Also be aware that this is a separate layer which can be turned on and off to compare it to the original image underneath.